Hello everyone. In this video, we are going to solve the problem number 1.51 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A rotating disk moves in the positive direction of the x-axis. So this is a rotating disk which is moving in the x direction, positive x direction, and it is asking to find the equation that is y as a function of x, that is describing the position of the instantaneous axis of rotation if at the initial moment the axis c of the disk was located at the point O after which it moved. So basically, let us say this is the point C through which the axis of this particular rotating disk is going through, and it is saying that at the time instant of t is equal to 0, the axis is passing through the point O. Okay, and in the first case, it is saying that velocity through which it is moving in the positive x direction, that is constant, and disk is rotating counterclockwise with a constant angular acceleration of beta. Constant angular acceleration of beta. Okay, and the initial angular velocity is equal to 0. So let us say initial angular velocity is omega naught, and that is equal to 0. So in this particular case, let us say it has moved by the certain distance of x, because velocity is always in the x direction, and this is the rigid body which is a rotating disk rotating anti-clockwise, and let us say the instantaneous axis of rotation is at a distance of y from point C as it is stated in the problem. So let us say this is the distance y. Okay, now this is the point which is the instantaneous axis of rotation. What is the meaning of this is when the body has pure rolling about an axis and that axis is called the instantaneous axis of rotation. Okay, so let us say this is the point through which the instantaneous axis of rotation is passing, and it is a distance of y from the x-axis. So here we can write beta is equal to d omega by dt. Okay, that we know. Second thing is that velocity is constant and the instantaneous axis of rotation is at the distance of y from the x-axis. So we can write velocity is equal to omega times distance. Okay, so velocity is constant, that is equal to omega into y. Okay, so from here we can write y is equal to v upon omega. We know that is given in the problem, that is constant, but we don't know what is the omega at a particular x. Okay, so from here we can write d omega is equal to beta into dt. Let us integrate both the sides from t is equal to 0 to t, and omega is equal to omega naught to omega, because at the time instant of 0 we are having the angular velocity of omega naught, and that is equal to 0. Okay, so we can get omega is equal to beta into t. Now let us substitute this particular expression of angular velocity in this equation. So we will get y is equal to v upon beta into t. Now the value of v and beta was given in the problem. Here we don't know what is the value of t. Okay, for that what we can do it is going with the constant velocity, right, in this particular direction. So we can write x is equal to velocity into time, and from here we can find t is equal to x upon v. So we can get y is equal to v divided by beta into x upon v. So from here we will get y is equal to v square by beta x. So this is the equation which is the hyperbolic equation. Hyperbolic equation because v square and beta both are constant and velocity is inversely proportional to x. If y is inversely proportional to x, that means it is the hyperbola. Now coming to the second part of the problem, that is b part. In the b part, it is saying that the acceleration is constant. Okay, here velocity is not constant and the initial velocity is equal to 0. While the disk rotates counterclockwise with a constant angular velocity of omega. So it is given that w, let us say this is the acceleration which is constant and angular velocity that is also constant. Now again we will assume that the instantaneous axis of rotation is at the distance of y from the x-axis. So again we can write omega is equal to v upon y. So from here we will get y is equal to v whole divided by omega. Okay, now in this particular expression we know the value of v, we don't know, so we have to find out the value of v, and omega we know because that is constant. So we can write the distance traveled is x, or we can write velocity square is equal to u square plus 2 into acceleration into, let us say it has displaced by the distance of x. Initial velocity is equal to 0, so we can write velocity is equal to under root 2 times w into x. So let us substitute the value of v here. So we will get y is equal to 2 times w into x under root whole divided by omega. So this is the expression of the y, that is at the distance of y from the x-axis, that is instantaneous axis of rotation, and that is directly proportional to root x. That means it is the parabola. So in both the cases we have found out the instantaneous axis of rotation as a function of x. I hope the entire procedure is clear. Thank you.